Right, right, yeah. It's not. Why is there this little chunk here, right? I mean, I'm not sure that we deeply understand all of the resonances and stuff that make these things possible. But yeah, yeah, there could be something out there, right? And so there's, I don't know. I don't know the answer. I don't know that we know, but yeah, there could be, right? So that's the deal. That's what's going on here. And this is, what's sort of interesting is that this is how you, by the way, make fission reactions happen. Is you just feed these nuclei a neutron. You just give it a neutron, and go, here, ingest this, and it goes, and then boom, it goes apart. And the funny thing is, it's not even a high energy neutron. A high energy neutron will go right through these nuclei. If it's going too fast, it'll just go right on through it, because these nuclei, I mean, don't think of like billiard balls glued together, a little hard thing. That's the small nuclei. Like an alpha particle is definitely a little missile, right? Okay, the large nuclei are just sort of like think lava lamp, right? Are you picturing kind of like something that's kind of like, oh, yeah, right? It's very loosely bound. These are loosely bound things. They're flying apart. We've got these nuclei are shedding energy like crazy because they're just like, oh, I'm too big. It's like you after Thanksgiving. Yeah, are you picturing that? Right? Okay, so really fast neutrons will just go right on through that and go, oh, was I supposed to interact with them? Right? They've actually got to go slow enough to be captured by the nucleus. Right? So we have these things called moderators that slow the neutrons down that make the reactions more efficient, which is kind of an interesting thing. Okay.
So how come the bigger, like uranium, is more stable and bigger binding energy than hydrogen?
Say it again. Oh, why does it have?
How does this graph?
Oh, it's binding energy per nucleon.
Okay.
Right, and so why is it? Well, I mean, what does the binding energy of hydrogen mean? Right, I don't know. Yeah, how do you calculate the binding energy of hydrogen? That's a good question. Nobody's ever asked that. I don't know. Maybe they just look at the energy released as you go up and interpolate. I don't know. That's a good question, right? Because what would you compare it to? Compare hydrogen to hydrogen. Yeah, that's a good question. Okay, so story. I'll ask that. I'll have to ask that. Nobody's ever asked that. Good question. Okay, so here's the story, right? I don't know if I told this last year, but I'm working behind the counter at the University of Minnesota, the Department of Physics. Right, there's these big buildings. There's physics and there's, I don't know, but chemistry was across the way, and there's right, and picture this big campus with these big colonial-looking buildings with the pillars on them or something like that, kind of like the Lincoln Memorial kind of thing, right? Only it's a school, right? And I'm behind the counter, and all I'm doing is running a Scantron. Be not impressed, okay? I'm behind the counter running the Scantron machine, which is behind the counter. And this nice man comes in with all these binders. He's wearing a suit. He's got little glasses, and he says to the secretary, the nicest person in the world, I'd like to speak to a physicist. And she says, no, I'm sorry, they're all busy. You have to, you can't speak to it. Sends him away, just like, please go. Right? And I'm like, gee, that's a little rude, So I stepped up to the counter and I say, mistake number one, right? I say, I know some physics. I thought maybe he was like a student. He had a question. I don't know, right? And there he goes, oh, good. And he puts his glasses on. He starts laying the binders out. And he goes, I've discovered 13 new elements. Yeah, happy feelings gone. No, you haven't. There aren't 13 more elements that you've discovered. Right? So I immediately know this guy's like a few fries short of a Happy Meal. And that's why the lady was like rude to him, because he probably sits and talks to professors for hours about very hard to, yeah, right? And I usually can't think on my feet, but this time I did. I go, before he gets all the things in, I go, this is more of a chemistry discovery. Now, right over there, that building over there is Smith Hall. That's the chemistry hall, okay? I think you should go talk to them. And he goes, really? And I go, yeah. Binders all get put away, out the door, right? The lady comes up to me right after he leaves and she goes, how did you get rid of him so fast? Usually he's good for at least a half an hour. And I explained the whole chemistry thing. She's like, chemistry? I like that. I thought that was